is continuous random variable? If the set of possible values of a random variable can assume any value in an interval on the real line, then the random variable is continuous. Example of continuous random variable. The weight of students in a particular class, the length of time a student spends in the library each week, the price of a concert ticket. The variables is about the weight, the length, and the price that can take any value in an interval. Probability density function. The probability distribution of the continuous random variable is also known as the probability density function and denoted by fx. The probability density function has the following properties. First, fx must greater or equals to 0 for all value of x. Let this graph be probability density function. The density curve must lie on or above the x-axis. So fx cannot be under the x-axis. The second property is the total area under the entire curve of fx is equals to 1 by doing the integration process from negative infinity to infinity. So if we can see from the PDF graph, when integrating from negative infinity to infinity will lead to get the total area 1. The third property is probability of random variable x at a is equals to 0. From the probability density function or PDF, here is a and x equals to a is just a line. Therefore, area of a line is equals to 0 because the area must be in an interval. The next property is probability of random variable x less or equals to a is equals to probability x less a, and getting from integration process from negative infinity to a of fx. This is the area under the curve represents probability x less or equals to a. Let's think about why probability x less or equals to a is equals to probability x less a. From the previous property, we know that probability x at a is equals to 0. That's why probability x less or equals to a equals to probability x less a. The last property of probability density function or PDF is probability of random variable x from a to b is equals to probability x from a to b not include a, and also equals to probability x from a to b not include b, and equals to probability x between a and b, and getting from the process of integration from a to b of fx, and the probability actually equals to the area under the curve of fx between x equals to a and x equals to b. Let's see the graph of probability density function. Here is a and b. So this is the area under the curve of fx from a to b. So y probability x from a to b is equals to 3 as a form. Since a and b is just a line, therefore probability x at a and probability x at b is equals to 0. Okay, now we are going to discuss about example 1. The probability density function, or fx, for the continuous random variable x is defined as follows. So, find the value of k and find the probability of random variable x as given. Solution 1a. This is the piecewise function represents the probability density function, or PDF. So in interval x from 0 to 3, fx is equals to x over 6 plus k, and fx is equals to 0 for otherwise. Or that's mean fx equals to 0 in interval x less or equals to 0, and fx equals to 0 in interval x greater or equals to 3. So the interval of x is from negative infinity to infinity. And this is the graph of fx. Since fx is probability density function, or PDF, the total area under the curve getting from integration process from negative infinity to infinity is equals to 1. Then how to solve constant k? So use the property of probability density function, which is integration of fx from negative infinity to infinity is equals to 1. I will use the real number line to help me in solving these questions. This is the real number line represents PDF in its interval x. So for fx equals to 0, it's in interval x less or equals to 0. Second interval, fx equals to x over 6 plus k in interval 0 to 3, and fx equals to 0 in interval x greater or equals to 3. So this real number line covered from negative infinity to infinity. The integration process will be done in that 3 intervals. First, the integration of function fx equals to 0 in interval negative infinity to 0. Then plus the integration in second interval from 0 to 3 for x over 6 plus k, and then plus the integration in third interval from 3 to infinity of the function 0 and equals to 1. So as a result, the first integration becomes 0, and the second is x squared over 6 times 2 plus kx from the limit 0 to 3, and then plus 0 equals to 1. Next, simplify the result of the integration and try to substitute with the following limit and solve for k. So k is equals to 1 over 12, and rewrite the probability density function. Solution 1b. Find the probability of random variable x at x equals to 2. So the answer is 0. Why? It is one of the property of probability density function, and it can be explained by the graph. It is just a line at x equals to 2. So the probability that x is equals to 2 is the area of a line, and remember the area of a line is 0. Next, find the probability of random variable x greater than 2. The graph shows the shaded area under the curve that represents the probability x greater 2. Don't worry, you don't have to sketch the graph. I just want to visualize the area for you to understand. So you can use the real number line from 1a. Here is at x equals to 2. The yellow area cross in interval x greater than 2. So, to find the probability, the integration process of probability density function must be done from interval 2 to infinity of the function f(x). Then integrate in the following interval. First, integrate from 2 to 3 for the function x over 6 plus 1 over 12. And then integration from 3 to infinity for the function 0. This is the result after integrating. Then substitute. So this is the answer of area under the curve or probability in interval 2 to 3, and 0 is the answer in interval 3 to infinity. And finally, we get the probability of x greater than 2 is equals to 1 over 2. Next, find the probability of random variable x that less or equals to 2.5. The shaded area represents the area under the curve in interval x less or equals to 2.5. So from the number line, the red arrow represents the area of x less or equals to from 2.5 on the number line. To find the probability, integrate the probability density function in the interval negative infinity to 2.5. So if we look at to the graph, the first integration will be from negative infinity to 0 for the function 0, and plus the second interval is from 0 to 2.5 for the function x over 6 plus 1 over 12. Then this is the result after integrating. Substitute for the answer, and the probability of x less or equals to 2.5 is 35 over 48. Find the probability x between 1 and 3. The graph shows the area under the curve or probability x between 1 and 3. So from the real number line, we can see that the blue arrow is in the interval 0 to 3 only. In this case, to find the probability, just integrate from 1 to 3 directly of the function x over 6 plus 1 over 12. So this is the result after integrating. Substitute to get the answer, and the probability of x between 1 and 3 is equals to 5 over 6. Okay, for the example 2, given a continuous random variable x with probability density function where p and q are constant, if probability of random variable x from 0 to 1 equals to 1 over 2, find the value of p and q and solve the related probability problem. Okay, solution 2a. This is the probability density function. We can graph it on a real number line which has 4 intervals. So first interval is x less or equals to 0 for the function f(x) equals to 0, and interval 0 to 1 for the function p(x) plus 1, then interval 1 to 2 for the function x plus q, and the last interval is x greater or equals to 2 for f(x) equals to 0. How to find constant P and Q? We can see that P and Q are the constant of the function f(x). Here is the given information. Probability random variable x from 0 to 1 not include 1 is equals to 1 over 2. Look at the blue arrow on the number line. The blue arrow represent the probability 1 over 2 from interval 0 to 1. Since this is probability density function, 1 over 2 is the area under the curve that getting from the integration process. Then, do integration in this interval of the function px plus 1 from 0 to 1 and equate to 1 over 2. Okay, this is the result after integrating. Then substitute. So finally, we get p is equals to negative 1. Our next goal is to find the constant q. Always use the property of probability density function to find constant, which is integration of f(x) from negative infinity to infinity equals to 1. This is the real number line. Okay, before that, we have to replace the constant p that we get from the previous solution. So based on the number line, integrate the probability density function in its interval. So first interval, integrate function 0 from negative infinity to infinity. From negative infinity to 0. Then for the second interval, integrate negative x plus 1 from 0 to 1. And third interval, integrate function x plus q from 1 to 2, and the last interval, integrate function 0 from 2 to infinity and equals to 1. After integrating, the result is 0 for the first interval, and then plus 1 over 2 for the second interval. 1 over 2 we get from the information from probability x from 0 to 1 not include 1. Then for the third interval, we get this form plus 0 and equals to 1. Substitute and simplify to find q. So q is equals to negative 1. Rewrite the probability density function. Next, find the probability of random variable x greater 0.2. Here is the number line of probability density function. Here is 0.2, and the green arrow represent of x greater 0.2. That means to find the probability, the integration process should be done from 0.2 to infinity for the function f(x) in the following interval. First, integrate from 0.2 to 1 for the function negative x plus 1, plus from interval 1 to 2 for the function x minus 1, then in interval 2 to infinity for the function 0. So this is the result after integrating. Then substitute and simplify to get 41 over 50. Find the probability of random variable x greater or equals to 1.5. Here is 1.5. The yellow arrow represents x greater or equals to 1.5. So the probability is solved by integrating from 1.5 to infinity for the function f(x) in the following interval. First, integrate function x minus 1 from 1.5 to 2 and plus Integrate function 0 in the interval 2 to infinity. And this is the answer after integrating. Substitute the limit and solve for the probability. So the answer should be 3 over 8. Now, let's solve probability of random variable x less or equals to 0.5. Here is 0.5 and the red arrow represents x less or equals to 0.5. So, to solve the probability of x less or equals to 0.5, the integration process should be done from negative infinity to 0.5 for the function f(x). From left of the number line, integrate from negative infinity to 0 for the function 0 and plus with integration from 0 to 0.5 for the function negative x plus 1. This is the result after integrating and substitute the limit and simplify to get the probability is 3 over 8.